In the last lesson, we learnt about the fact that AC current and voltage has an average of 0. And so we found a better way to calculate the average, and that was by using the root mean square. And we said that that's equal to the maximum voltage divided by the square root of 2. And for current, we can do the same. So that's I max over square root of 2. We also saw that average power is equal to VRMS multiplied by IRMS, or we also saw that P max, which is the maximum power, I should rather say average power, is equal to the maximum power divided by 2. So these are the different things that we need to know. Now here's our question. It says that a microwave is using an average current of 5 amps while connected to an AC voltage source with a max voltage of 250. Okay, so they've given us average current, which is actually called IRMS. We don't use average, we rather use the root mean square. And then they've given us the maximum voltage. They've given us V max. And they want us to work out the average power of the microwave. So we know that average power, you must use RMS and IRMS. Now we know that the current RMS is 5 amps, but we don't have the root mean square voltage. And so what we can do is we can see that the voltage for the root mean square should always be the maximum divided by the square root of 2. You see I'm using this formula up over here. And so that's going to give us the maximum voltage of 250 divided by the square root of 2, and that gives you 176.78 volts. Okay, so that's the root mean square voltage. So now I can work out the average power as 176.78 multiplied by the average current, which was 5 amps, and that's going to give you 883.9 watts, because power is measured in watts. Question B says determine the resistance. So we know that resistance could be calculated using I equals to V over R. Now with resistance, you don't get RMS resistance or maximum resistance. Resistance is an easy one. Resistance is a constant. So if I had to rearrange this equation, I would get R is equal to V over I. Now it doesn't matter what V or I you use, as long as you use the right combination. So what I mean by that is the following. If you choose V maximum, then you must also choose I maximum. If you choose V RMS, then you should also choose I RMS. You will get the same value. So what I'm going to use is I'm going to use the RMS values. So that's going to be voltage RMS, which we said was 176.78. Sorry, let's keep it in blue, 176.78. And then because I'm using the voltage RMS, I must use the current RMS, and that's going to be divided by 5. And that will give you 35.36, and resistance is measured in ohms. If you chose to use the maximum values, you would get the exact same answer. Here's another question. So they tell us that a lamp has an average power of 30 watts and is connected to an AC voltage source as shown below. So here we can see there's an AC voltage source with a peak voltage of 20. It says here, calculate the maximum current in the lamp. So we know that they've given us power over here and they've given us average power. So we know that average power is IRMS multiplied by VRMS. Remember, you mustn't use the maximums over there. Now we know what the average power is, it's 30. But we don't have the voltage RMS. This 20 volts is the maximum. But we know that if you want to calculate RMS voltage, you just take the maximum and you divide it by the square root of 2. And so that's going to be 20 divided by the square root of 2, and that's going to give us 14.14 volts. So now we know what the RMS voltage is, so we could use this formula here, which is 30 equals to IRMS times by VRMS, which is 14.14. And then you could get IRMS alone by saying 30 divided by 14,14, and that's going to give us 2,12 ohms. Sorry, not ohms, what am I talking about? Amps, that's current. But the question wants us to find the maximum. So what we can now say, well, we know this formula, IRMS is equal to Imax over the square root of 2. So if we're looking for Imax, then we can just multiply by square root of 2 to get Imax alone. And so now we can see that Imax is going to be equal to 2,12 multiplied by the square root of 2, which gives us exactly 3 amps. And so that would be the maximum current. The next question asks for resistance. So we know that I is equal to V over R, and if we rearrange that, we get R is equal to V over I. Now, you can use any voltage or current as long as it matches. So we said that if you use the maximum voltage, then you must use the maximum current. If you use the RMS voltage, then you must use the RMS current. The answer that you get will be the same. Please remember, you mustn't call it the R, you mustn't have like a R maximum and a R RMS. It doesn't work like that. Resistance is a single value. But Kevin, how can we use two different voltages and currents and get the same answer? Guys, it's just the way that the maths works. The square root 2 cancels out. But to help clarify that, let me use both. So let's say I use the maximum voltage and the maximum current. Well, the max voltage is 20, and the maximum current we calculated as 3. And if you had to work this out, you'd get 6,67 ohms. Now I'm going to use the RMS values. So we already worked it out previously that the RMS voltage is 14.14. and the RMS current was 2.12. And if you had to go divide those, you get exactly 6,67 ohms. So it doesn't matter what you choose for resistance, you will get the same values, as long as you match it properly. So if you use the maximum voltage, use the maximum current. If you use the RMS voltage, then use the RMS current. There we go, guys. Thank you very much for watching.